Here's your practice test. So, number one, complete the table for the function y is equal to -2 times e raised to the x power. Round each value to the nearest tenth. So, again, all you're doing is you're just plugging in y is equal to -2 times e raised to the negative first power. And on that one there, you should get negative 0.7. Anything raised to the 0 power is equal to 1. So then we'll have -2 times 1, which will equal -2. And so on. Just plug them in. So here you should get -5.4. And on this one here, you'll get -14.8. All right, just plug and chug, ladies and gentlemen. So number two, match the equivalent values. So remember, when we had something like this, what I suggested is you make it equal to something, and I used x. So then remember, this base raised to this power equals this. So what did I just say? This base, which is 8, raised to the x power is equal to 64. So on that one there, we can rewrite 64 as 8 squared. So again, when the bases are the same and it's equal, that means that the exponents have to be equal. So we're going to say that x is equal to 2. So we can get rid of that one. All right, same thing here. 64 raised to the x power is equal to 8. Well, in this one here, you have to kind of think, well, 64 raised to what power? Well, again, you would know you'd square root it, right? So remember, square root would be to the 1/2 power, and that will equal 8. So again, we're told that x is equal to 1/2. All right, and remember, you can only use them once each. So on this one here, we're saying, oops, sorry. And set it equal to x 1/2 raised to what power equals 8. Well, remember, I'm going to need to flip it, so that means I'm going to have a negative there. And to what power equals 8. So you would tell me on this one here, x is equal to -3. And if we plug that in, okay, and you can always just plug them in your calculator like that, okay? Remember, I noticed on Desmos you can't do 1/2, so you would have to say 0.5, okay? And then the last one here, just because I've already used those ones, we know that the last one has to be -1/3. Okay, next ones are just, again, plug and chug. So remember, that's log to the base 10. It's the common log and the natural log. Plug them in your calculator. Gave you a couple of easy ones here. That'll give you 0.602. Again, they said 3 decimal places. And on this one here, -0.105. Okay, remember, excuse me, to find an inverse, what you're going to do is you're going to change the x and the y. So we're going to say x is equal to e raised to the y plus 3 power. Okay? Now remember, how do I get rid of, remember, I have to bring that y down now. And how do I do that? Well, I have an e there. So if I take an ln on both sides, because that was our definition, those two are going to go away. And that side is just going to become y plus 3 is equal to the natural log of x. And to get y by itself, I'll have the natural log of x minus 3. Okay? Okay. Again, number 5, ladies and gentlemen, we've done this so many times, that we should start getting good at it. Remember, I told you that they always have us do an h of x, so it looks like we're doing one thing and two things here. So our h of x will equal 1/2. The vertical shrink is on the outside, so it'll be 1/2 times f of x, or 1/2 e raised to the x power. Okay, now g of x, we'll take, again, since it's up and down, that is outside again, so I'm going to take h of x and plus 2. Remember, that one carries the same sign. All right, and then I'm going to just have 1/2 e raised to the x power plus 2. All right. On number 6 here, again, remember, they're trying to get you to remember your log rules. So remember, on this one here, we could write this as log to the base 6 of 9 times 11, right? And remember, when I'm multiplying, I can write that as log to the base 6 of 9 plus log to the base 6 of 11, which in this case would be 1.226 plus 1.338. If you work that out, you get, what did I get? 2.564. All right. On this one here, you can write it as log the base 6 of 11 times 11 and then add it, or you can remember it's log to the base 11 squared, which I'm going to move it over here now, because remember, I can write that as 2 times log of 11. So that would be 2 times 1.338. And that one would give us 2.676. Right? So again, same kind of thing. Remember, this one here I can write as, let's go to my color. This one here I can write as log. Remember, when I'm dividing, I'm just going to subtract them. Log to the base 11 minus log to the base 6 of 9. And if you work that one out, you get 0.112. And then by elimination, you'll see that the last one is 2.452. Number 7, remember, when I say expand, that means I have something all by itself. Now I'm going to make it be a lot longer. So remember, on this one here, I can write this as the natural log of x cubed. Since it's division, that means I can subtract them when I separate them. And then remember, now I have to take those powers and bring them down in the front. So I should have 3 to the natural log of x minus 2 natural log of y. Okay. Condensing means I'm doing the opposite of what I just did. I have more than one L in there. I need to just get 1. So we have 3 there. What we have to do is make them 1. So on this one here, I can look and I can see right now that I'm going to take the natural log of 4, and I'm going to make that a square. And then I'm going to take the natural log of x, and I'm going to cube that. And then I'm going to take minus the natural log of y, and I'm going to raise that to the 4th power. Okay? So now I'm going to look at this, and I'm going to take these two together. All right? So now to get them together, minus means I'm going to divide. And 4 squared, 4 squared is 16. So just go ahead and write that as the natural log of 16 plus, we just said what? The natural log of x cubed on the top. Y raised to the 4th power is going to be on the bottom. Okay? And now remember, the plus means I'm going to times. So on the top one there, I'm going to multiply the 16x cubed. And then I'm going to leave y to the 4th on the bottom. And you should put that in parentheses. And that's that one. Okay. On this one here, you can just plug it into your calculator. Remember, on some of them, you can just put that log to the base on the bottom there. So you could just plug it in and you should get to the nearest thousandths. So that's 3 decimal places. So that'll be 1.277. And if you have a calculator that won't allow you to do this, remember what I showed you was the change of base formula. So let's say, or change of base formula. Which remember is either the common log or the natural log. So you could say log of 12 over log of 7, and you'll get the same answer. So you can use either one. And again, that will still give you 1.277. Excuse me. Number 10. The natural log of 5x plus 18 is equal to the natural log of 12x plus 4. Remember, when I have a natural log on each side, I can just say then that 5x plus 18 is equal to 12x plus 4. And remember, we're going to solve for that. So I'm going to subtract the 5x. So 12x minus 5x is going to be 7x. 18 minus 4 will be 14, or x is equal to 2. Okay, remember on these ones here, when you plug it back in, if you end up with a negative in this area here, it won't work, all right? Even here, okay? So remember that, because that's what's going to happen on this next problem. So on this one here, let's see. Select the solution or solutions of log to the 2x equals 1 minus log to the x plus 4. So on this one here, I'm going to bring this over to the other side because, again, my goal is to get 1 log. So I can see that. So I can have 1 common log. So I'll say then I have log to the 2x plus log to the x plus 4 is equal to 1. Okay. Then I'm going to take, and remember, I can now, since I have that plus there, I can multiply them together. So I can write that as log to the 2x times x plus 4 is equal to 1. Now remember, this log is raised to the 10th. So again, once we get to here, think this base raised to this power equals this. All right? So 10 raised to the first power, well, that's just 10. All right? So I'm going to rewrite it. And so I can rewrite that, and I'm going to take it over here. I can write that as 2x times x plus 4 is equal to 10 to the first power, or just 10. Okay? Now I'm going to go ahead and put this as 2x squared plus 8x is equal to 10. Remember, my goal is to solve for that, so I'm going to subtract 10 and set it equal to 0. Okay, on this one here, I want you to think I can factor out a 2. And then if I divide, 0 divided by 2 is 0. So on this side here, I'm going to get x squared plus 4x minus 5 is equal to 0. Okay, so now once I'm done with that, okay, remember I told you before, okay, since I have a coefficient of 1 there, I'm going to do x and I'm going to do an x here. Since this one is negative, I know right away one is going to be positive and one is going to be negative. And what are factors of 5 that when I add them will give me a positive 4. So I'll have plus 5 minus 1 is equal to 0. Okay? So now, by the zero product property, I know that x is equal to negative 5 or x is equal to positive 1. But I want you to think here. When I plug in this negative 5 up here, what is negative 5 plus 4? That's negative 1. Even if I plugged it in on this side, 2 times negative 5 is negative 10. What did I just tell you earlier? We can't have negative logs. So even though it came out, remember, this is an extraneous solution, so that one doesn't work. So the only one that will work is this one right here. Okay? Number 12. On this one here, again, remember your goal is to get the x by itself. So the first thing you're going to do is you are going to multiply each side by 2. So we'll get e to the 2x is equal to 9 times 2, or 18. Okay, now it's just like we just did one like this earlier. How do I get rid of a e? Well, all natural log both sides. All right, so those are going to go away, and what the 2x comes down is equal to the natural log of 18. And then I'm going to divide by 2 to get x by itself. So the natural log of 18 divided by 2. So put it in like that, ladies and gentlemen. All right. So a lot of you all put in natural log of 18 divided by 2, put those together, and that's not your correct answer. And again, it says to the nearest thousandth, so that's 3 decimal places. So you should get approximately 1.445. Okay. Notice how we're just zooming here. All right. Now on these ones here, ladies and gentlemen, the simplest thing to do is maybe plug in a positive number for A and a positive number for H. So remember, when H is positive, it moves it to the right. All right, so if we look at that, it's going to move it to the right. And remember, if it's positive and H is positive, you're going to have one that goes up. All right, since you're going to have one that goes up and it moves it to the right, that would be this one right here. So that is the one that should go there. Right, when H is positive, when A is positive and H is negative, so on that one there, all right, it's the same thing. It's still going to go up, all right, but now it's going to be shifted to the other way. So what's the only one that goes up and shifts the other way is this one right here. So again, it's a drag and drop. On this one here, remember, what happens when you have A is negative? All right, that's a reflection. So it's a reflection over X. Here, let's use a different color. So let's see. When it's a negative, it's a reflection over x. And that's the only thing that changes. So let's see which one looks like this one, except it's reflected. Oh, it looks like it's this one here. So that one will go here, and then by elimination, again, this one will be right here. Okay. Same thought process on these ones here. Again, remember, all a log is the inverse of an exponential function. So on this one here, I'm just going to go ahead and show you. Plug in, like I said, if you're not sure, put in an H, put in an A, all right? Like on this one here, you know, it's x minus 8, so the H is positive, right? And if you look at that one, that's going to be this one right here. And then I'm just going to show you all of them this time. This one right here would be the next one because it's following the same pattern. Let's see. This one right here would be right here. So that means that the last one has to be this one here. And that goes there. Okay. All right, write an exponential function y is equal to a times b raised to the x power, whose graph passes through 2 and 12 and 5 and 96. So remember, on this one here, we called this our x and our y, and we called this our x and our y. So remember, step 1, I told you to write it down. So 12 is equal to a times b raised to the second power. Okay? This one is a, let's see, 96 is equal to a times b raised to the fifth power. I told you to solve the first one, so solve the one with the smaller exponent on b, solve that for a. So I would divide both sides by b squared, so a is equal to 12 divided by b squared. And then you're going to plug that into your other one. So we're going to get 96 is equal to, our a on that one is now 12 over b squared times b to the fifth. So remember, that b to the fifth and b squared, remember, you'll be able to get rid of that one there, and you'll get rid of 3 there. So you'll get b cubed. All right? So now let's solve that. So now I'll have 96 is equal to 12b cubed. All right? Or if I divide by 12, I'll get b cubed is equal to 8. How do I get rid of a cube? I cube root it. So b is equal to the cubed root of 8. And we all should know by now that that is just equal to 2. All right? So our b is equal to 2. So now we're going to plug that into our a first one. So we can say a is equal to 12 divided by 2 squared, which is 12 divided by 4, which is equal to 3. So now our equation is right there. So we are going to say that our equation is now y is equal to 3 times b, which is 2, raised to the x power. And that is your answer. Okay. Number 16, the population of a city is 250,000 and the annual growth rate is 2.2%. So write an equation to model the population Y after X years. So remember, our formula was Y is equal to A times B to the X, or we could write it as Y is equal to A times, since we have that rate, 1 plus or minus R. Since it's a growth, we're going to say plus R raised to the X power. So remember, change this to a decimal. All right. So if I change that to decimal, remember I'm going to go 1, 2. So it looks like 2.2% is going to equal 0.022. All right. So now we're going to say Y is equal to our initial amount is 250,000 people. And we're going to have 1 plus 0.022 raised to the X power. Of course, they'll want you to simplify that. So you'll have 250,000 times 1.022 raised to the X power. Let me make that X look a little nicer. Sorry. And there's your answer. Okay. Number 17. Boy, a lot of word problems on this one today. So, the amount Y in grams of the radioactive isotope phosphorus-32 remaining after T days is Y is equal to A times 0.5 raised to the T divided by 14th power, where A is the initial amount in grams. What percent of the phosphorus-32 decays each day? Round your answer to the nearest hundredth of a percent. So on this one here, we are going to use our formula. Y is equal to 1 minus R raised to the, in this case, T power. All right. So to get that, remember, we can say that 0.5 raised to the T divided by 14th power is the 14th root of 5/10 raised to the T power. All right. So knowing that, 14 to the 0.5 power is equal to 0.951695. You don't have to round it that far, but they do say to the nearest hundredth. So remember, my suggestion is at least 4 decimal places. But if I take that, now remember, my 1 minus R, that's my rate. The R is my percent that I'm going to have to find, right? Is equal to 0.951695. Okay, so again, to get, I'm going to have negative R is equal to 0.951695 minus 1, or I'll get negative R is equal to negative 0.0483. And again, since they're both negative, then I can say that R is equal to 0.0483. And again, I have to change that to a percent. So change that to a percent. I'm going to move it 2 decimal places. So I'll get 4.83%, which is their, again, that's to the nearest hundredth. Hundredth is 2 decimal places. Okay, let's see. Number 18, you deposit $4,000 in an account that pays 2.88% annual interest. Find the balance after 2 years when the interest is compounded monthly. So remember, on this one here, our formula was, and still is, A is equal to P times 1 plus R divided by N times N times T. Okay? Where N is how many times it is compounded. So it's compounded monthly, so N is going to be equal to 12. Our R is going to equal 2.88%. Remember, now I have to change that to a decimal. So it's going to be 0.0288. And then our T is equal to 2 years. So if I plug that in, remember our initial amount, our principal is $4,000. Then I'm going to have 1 plus 0.0288 divided by 12 raised to the 12 times 2 power. Plug that into your calculator. Of course, it will be 2 decimal places because it is money, and you should get 4,236.87. Okay, number 19 uses Newton's law of cooling. So remember, Newton's law of cooling, we said, was T is equal to T sub 0 minus T sub R, which is the room temperature, times E raised to the negative RT plus the room temperature. So remember, let's see here. What do we want to do? We want to cool our food to 100. So that's the temperature we want. So we're going to say 100. T sub 0 is our original temperature, which was 200. Our room temperature is 72. I'm going to say E raised to the negative. Our R is 0.054 times T plus our room temperature, which is 72 degrees. All right. So now I'm going to subtract 72. So 100 minus 72 will be 28. Okay. 200 minus 72 is 128. And then we'll have E raised to the 0.054 T. Okay. Now to get E by itself, I'm going to have to divide by 128. So I'm going to have E to the negative 0.054 T. I'm glad they gave me this extra room. And that's going to be 28 divided by 128. Okay. So, oh man, we just did something like this before. Ladies and gentlemen, I need to get rid of that E so I can bring the T down. So how do I do that? Well, I natural log both sides. Okay. So if I natural log both sides, that'll tell me that I get negative 0.054 T is equal to the natural log of, I went ahead and divided 28 by 128, and I got 0.21875. And again, to get T by itself, now I'm just going to divide by negative 0.054 And if you work that out, that is a negative there. You got that t is equal to 28.1449. But what did they tell us to do? Round it to the nearest minute. So it'll be 28 minutes. Okay. Guess you'll just have to give them another soda while they're waiting for it to cool down. And finally, our last problem is one that was kind of our last problem on our notes too, was where we would go and plug this into our calculator using a table. So a company launches a new website and tracks the number of visits to the site. Predict the number of visits on the 10th day. All right. So first of all, what we have to do is we first have to go and make a table, which I've already done here for you. Remember, you do that by hitting the plus sign here. All right. Now remember, you want to be able to see it. So if it looks exponential, so you would go to this little zoom here, zoom fit. And if you look, it zoomed in for us, and it does look nice and exponential. In fact, what I found out is if I do this, if I put projector mode there, it kind of makes it look bigger for you. So now remember on this, and I'm going to do this again. So I'm going to hide that toolbar there because that's what screwed me up the last time. So if I show my keypad here, remember I want Y, and it needs to be sub 1. So to get that, I'm going to go here. So I'm going to get Y sub 1, and then you'll probably want to shift it because we don't want it to be there. All right. And then I am going to do the tilde here. So that'll show us regression. And remember, I need it to be raised as a times b raised to the x power. So on this one here, I'm going to put a, because I don't know what it is yet. And then I'm going to put in b. So remember, I have to put that in parentheses. And where's my b? And let me close my parentheses. And that will be raised to the x power. But remember, I'm going to say x, and then I have to make it as sub 1 also. So if I do a sub 1 there, so that's right here. And then I'll do a 1. And look at how nice that looks. And there's our A, and there's our B. All right. So I'm going to go back to my other one. So just remember those. You probably should have written them down somewhere, which I did. So what we're going to say here then is that we get that. So let me say that again. I'm going to say table in Desmos. Then you'll get Y is equal to 5.0114. And then I just used 4 of them. I know I had another one, but the B was just to the 4th decimal place. Okay. And then you're going to say when X is equal to 10, you'll plug that in. So you get Y is equal to 5.0114 times 2.9987 raised to the 10th power. And if you work that out, ladies and gentlemen, you get approximately 294,638. So as you can see, the closest that is to is about 3,000. Okay. Test is going to be exactly the same, ladies and gentlemen. Good luck to you.